Good afternoon, geometry students. I hope you're having a fantastic day. We are doing notes for section 3.5a. Now you should be watching two videos at the time you watch this video, 3.5a and 3.5b. The reason we have two videos is that the book assumes that you already know everything about slope before lesson 3.5b, and I know that many of you you may have learned about slope but not remember it, or you may have actually never been taught it depending on where you went to school or your teacher or whatever. So I just want to make sure that we all are on the same page with regard to slope. So we're going to do lesson 3.5 in two pieces, A and B. The first part right now is 3.5a, and what I'd like you to write is slope, 3.5a, and then write the word slope. Okay, so you've probably heard of slope before. You know, when you go down the mountain, you ski down the ski slope, and so you can see where they might have used that word to describe how steep something is. But the basic definition of slope is rise over run. Now, when you get into advanced algebra, you will talk about it more in the context of average rate of change. But for right now, we're going to call slope the letter M. So M is kind of a nickname for slope. And it stands for rise over run. When you're measuring how steep a line is, how much do you go up and then over to get to the other point on that line. So we're just going to do a few examples of different ways to calculate slope. And I think, you know, if you have graph paper, it might make it a little bit easier to do these notes. You don't have to use graph paper, but it would be helpful. And so I'll try to go sort of slowly, and then you should also feel free as normal to pause the video as you need to. So let's go ahead and do example number 1 of calculating slope. The points we're going to graph are 1, 2, and 4, 4. 1, 2, and 4, 4. So I'm going to draw an XY axis here and graph those points. Now to graph 1, 2, we would go over 1 and up 2 and put a dot. And then to graph 4, 4, we would go over 4 and up 4. And I'm just going to kind of freehand this in the interest of time. You can see that we have a line when we connect the 2 points. Now, slope, as I said, means rise over run. So we have a rise of 1, 2, because we're going up 2, and a run of 3. So we're going up over 1, 2, 3. So the slope of this line would be 2/3. Now, the cool thing about slope that you might not know, and I had a hard time believing this when I first learned about slope, is it doesn't matter which point you start at. I would get the same answer if I started at this point and went down and then back. So if I start at 4, 4, I could go down 2, which would be -2, and then back 3, which would be -3. Can anyone guess why these answers end up being the same? Why is 2 over 3 technically the same answer as -2 over -3? It's because when you have a negative divided by a negative, they cancel each other out. So no matter how you count your slope, as long as you count your rise first and then your run, you should get the correct answer. Now, a lot of times it's not really practical to draw a picture. And so there is a way you can calculate slope just using a formula. Let's use the points -3, 6 and -7, 3. So -3, 6, and -7, 3. I am going to give you the slope formula up here. We'll add it to the top of our notes. It's y2 minus y1 over x2 minus x1. Some of you might be saying, what are those x's and y's? What I want you to do is to label your points with an x and y underneath them, put 1s on the first point and 2s on the second point. And again, ideally you would be watching this YouTube video on your phone so you can zoom in and see the video a little bit better. Now what I want to do is plug in the information from these points into my slope formula. So y2 is what number? Did you label your points? If you did, what number did you label y2? Hopefully it was 3. So you're going to go 3 minus 6 over, and then your x2 is -7, so you're going to write -7 minus -3. Now notice there are 2 minus signs there. There's one minus sign for my formula and another minus sign for the number. When I have 2 minus signs in a row, that turns into a positive. So this becomes -3 over -4. And again, as I mentioned before, these negatives cancel each other out. So the final answer is just 3/4. Now, what I'm going to do is tell you a few other pieces of information. So these were like calculation examples that I just did with you, but I also want to talk to you about the different answers you can get when you do a slope problem. So when you calculate slope correctly, you're going to have one of 4 different answers. So one possibility is that your answer is a positive number. So if you have a positive slope, that is going to represent a line that is going uphill. Another type of slope is negative. So that means as you look from left to right, the line that you're calculating the slope for is going downhill. Does anybody know what the 2 other possibilities are? This is positive, this is negative. What might be another choice? Another answer is 0 slope. So 0 slope is when you have a completely flat line. We call that a horizontal line. And what I like to say here is if you write the word 0, the capital Z has 2 horizontal lines in it. And that's one way of memorizing that a horizontal line has a 0 slope. Now, there is a 4th possibility, and that is a vertical line. If you have a completely vertical line, it has no slope. We call that no slope, or we can say undefined slope. Either way is considered to be correct. No slope or undefined slope. All right. Now, what I want to do is tell you one of the reasons why we learn about slope is so that we can compare lines. In geometry, as you know from earlier in this chapter, we often talk about parallel and perpendicular lines. So it's super important to know how the slopes compare. So I'm going to give you some more information from your notes. Parallel lines have can anyone finish? How do the slopes of parallel lines compare? Think in your head what 2 parallel lines look like and ask yourself how their slopes would compare. Parallel lines have the same slope. They're going to be the same amount steep. And then the other fact you need to know is perpendicular lines have what's called, does anybody know what perpendicular lines have? Opposite reciprocal slope. Opposite reciprocal. Some of you are going, what the heck is opposite reciprocal? Opposite reciprocal has 2 parts to it. Opposite means different sign, so positive versus negative. Reciprocal means the numbers flipped. So let's do an example. What would be the opposite reciprocal of -1/3? Think for a minute. What would be the opposite reciprocal of -1/3? Well, we have to have the opposite sign, so if this one is negative, ours would need to be positive, and we need to flip it. So instead of being negative, this is going to be positive, and instead of being 1/3, it's going to be 3/1. Okay, let's try another one. Let's try the slope 7/8. 7/8. 7/8. what would be the opposite reciprocal of 7/8? Well, opposite means it has to be negative because this one's positive. And instead of being 7/8, it would be 8/7. So the opposite reciprocal slope of 7/8 is negative 8/7. I think that's the gist of what you guys need to know. This is fairly basic. We are going to do more examples as we go over the homework, but I wanted you to have some definitions, the formula, and the different possible types of answers to work with. Thanks, guys. Talk to you soon. Okay, bye.